Hello everyone. In this video, we are going to give a detailed explanation for an Arduino board using a temperature sensor. So in this code, I'm going to read an analog value that will be written a value from 0 to 1023. That is 2 power 8. So in this Arduino board, we are going to connect a temperature sensor named LM35. It is a popular analog temperature sensor that provides a voltage output proportional to the temperature in degrees Celsius. So we will get a output in the form of degree or Celsius. So using that LM35, that outputs a voltage of 10 millivolts per degree Celsius. So at 0 degree Celsius, the output will be 0 volt, and at 25 degrees Celsius, the output will be 250 millivolts, that is 0.25 volts, and at 100 degrees Celsius the output will be 1 volt. So this basically runs on operational range. That operational range is between 55 degrees Celsius to 150 degrees Celsius. So accuracy, why we are using this LM35 temperature sensor is the LM35 sensor provides good accuracy of temperature. This is so that we are connecting the LM35 to an Arduino Mega board. So I'm going to show the code I have written for the LM35. So here is the code for LM35 temperature sensor. Here I am using a global variable float temp. This float temp is used to read the temperature from the environment from the analog pin. So I am using a void setup function. This void setup function is used to set up the pins we are going to use in this Arduino simulation, and to begin the serial communication between the board and the temperature sensor. So using this pin mode keyword, I am setting this 15th pin as an output pin. This 15th pin will get connected to a resistor, to a LED, to grounded. So after that I am using a serial begin keyword. This serial begin keyword is used to begin serial communication with the board. So inside this bracket I am giving 9600. This 9600 means that is a baud rate of the serial communication to be begin. So this initialize the serial communication to enable the data transfer. So we are going to transfer the data, so that I am going to use the serial pin. And then inside I am using another one function named void loop. This void loop function is used to read the analog value from the pin A0. So I am going to use this keyword analog read bracket A0. I am giving A0 means it is an analog pin. There are 6 analog pins in our Arduino normal board. So I am giving the temp equal to analog read A0. So we are going to read the temperature from the A0 pin. So this A0 pin will get connected to the LM35, that is a temperature sensor, and I am using a formula for calculating the temperature. The temperature we are giving from A0, then it will come to temp equal to temp star 500 divided by 1024. That is the temperature we are multiplying with 500 and divided by 1024. 1024 we are using because the value will be 0 to 1024, because the sensor we are connecting is a 8-bit sensor. So 2 power 8 will results at 1024. So 0 to 2023 will be the value ranging. So serial println I am printing the visual terminal temp, and then if comparing this temperature, now we got a temperature from this value, this formula. So I am comparing the temperature is greater than 30. If the temperature is greater than 30, then digital write 15th high. This means the 15th pin we are connected to a LED that will blink, so that if the temperature is greater than 30, the LED is blinking, else the LED will low. LED is low means the LED is in off position. So I am giving a delay operation of 1000. This delay operation makes the loop pauses for 1 second before the next iteration. So this is the code. So I am going to run this code. Check once it is in Arduino Uno board. So because we are using Arduino Uno, make it as Arduino Uno and do compiling. Now the data is getting compiled. After it's getting compiled, we want to extract the hexadecimal file from this compilation, and then dump the hexadecimal file into the board, Arduino Uno board we are using in the Proteus software. So using this hexadecimal file, it's easy to dump the whole code into the board. So here the hexadecimal file .hex, this file we are getting. So this path we want to copy till here, only this hexadecimal file we want to copy this. And I have done the simulation already in the Proteus software, so I am going to show the Proteus simulation using Arduino and LM35 temperature sensor. This is the Arduino Uno board we are using, and this is the temperature sensor we are using named LM35. There are 3 pins in this, and 1 pin is get connected to the ground, 1 pin is get to the power source, and the another pin is connected to the A0. Here we are getting the temperature from the temperature sensor to the A0. As I mentioned in the code also, the same we are connecting it into the A0 pin, and I am using a visual terminal. Visual terminal's receiver will connect it to the Arduino board transmitter, and visual terminal transmitter is connected to the Arduino board receiver. So that 13th pin is connected to a resistor of connected to the LED to the ground. So this is the simple structure of the Arduino Uno board with the temperature sensor LM35. So now I am going to dump the code into the hexadecimal file into the board. So I am copying and pasting the hexadecimal file where we copied in the Arduino IDE. So now I given OK. Now the code got dumped into the Arduino Uno board. Now I am going to simulate the simulation. After getting simulated, this LED will get blinked and the temperature will be shown in the visual terminal. So now I am going to compile the simulation. Yeah, now the simulation is getting compiled. The visual terminal has been came. Now the temperature is showing as 17.58. After some times the volts will get increased, and then the temperature will be get increased 29.30 now. After that the volts will get increased simultaneously, and the temperature will also get simultaneously increased 29.30. We are comparing the temperature is greater than 30 or not. If it is greater than 30, the LED will get blinked. If it is less than 30, the LEDs won't get blinked. So till now the temperature is being 29.30, 17.58, so that the LED is not getting blinked. After, if it is the temperature is getting increased after 30, then the LED will get blinked. We want to wait if the temperature is getting increased or not. Yeah, this is the simple simulation to connected to an LM35 temperature sensor to see that the temperature is being recorded in a visual terminal. Thank you.